Today's lesson is called Is There a Pattern Here? And we'll be recognizing patterns and sequences and doing a little predicting. During the warm-up, you were asked to write the next 3 terms in each pattern and explain where they came from, how you generated them. Well, hopefully in number 1, you recognized that these were the months of the year, or the first letters for the months of the year. So we have January, February, March, April, May, June, July, August, September. So then the next 3 would be October, November, and December. And if you got that, then you probably figured out that the next one was days of the week. Sunday, Monday, Tuesday, Wednesday. Then we would have had Thursday, Friday, and Saturday. And in number 3, we are adding 5 each time, 5, 10, 15, 20. So then we would go to 25, 30, and 35. And in the next one, probably the hardest one, it's hard to figure out how you go from 100 to 81. That would be, subtracting 19? But if you subtract 19 from 81, it doesn't get you 64. So it's something else. And what this is actually is all 4 of them are perfect squares. 100 is 10 squared, or 10 times 10. 81 is 9 squared. 64 is 8 squared. 49 is 7 squared. So the next 3 are going to be 6 squared, or 36. 5 squared, or 25. And 4 squared, which is 16. Our learning goals for today are that we want to recognize and describe patterns, kind of like we did in the bell ringer or the warm-up. We want to represent patterns as sequences and predict the next term in a sequence, sometimes more than just one. And we're going to represent a sequence as a table of values. So we're going to put these numbers into a table, kind of like a T-chart. The key terms for today are sequence and term of a sequence. In the next lesson, we'll get into infinite and finite. Since elementary school, you've been recognizing and writing patterns involving shapes, colors, letters, and numbers. How are patterns related to sequences, and how can they be represented using a table? This first slide here talks about something called Pascal's triangle, which is kind of a famous mathematical thing, and it's named after a famous mathematician named Blaise Pascal. And in this pattern, we're asked to find at least 3 patterns that we notice that's going on here. Well, for me, the first thing that I notice is that this is organized in kind of a symmetrical way. So if I draw a vertical line down the middle, that everything that happens on the left side of that line is mirrored on the right side of the line. That's the first thing that comes to mind for me. The next thing that comes to mind for me is the number of terms in each row. In the first row, there's 1 term. In the second row, there's 1, 2, then 3, then 4, 5, and so on. So we're always adding 1 more number or term in the subsequent row. And the last thing, and probably the most interesting thing to notice, is where do the numbers come from? Well, the first number is just 1, and the second one is 1, 1. In the third row, it starts to change a little bit. We always start and end with 1, but where does the middle number come from? Well, the middle number comes from those 2 numbers being added together. So then on the next row, when I add 1 and 2, I get 3. Well, I do it again here. That's why it's symmetric. And so if you add 2 numbers on a row, the number directly below it is that sum. And that happens all the way down. I think you'll see.